Hi, my name is Nick Levitt. I have 8+ years in software design and architecture.
Hi, my name is Ben Moxon. I have extensive experience with Verilog and 4+ years with programming and software.
My name is Nick Rouleau. I have experience working with Bitcoin mining, HDL programming, and working with CAD software.
Hi, my name is Yoon Peng, and I have some knowledge in digital logic designing, circuitry, and Verilog through ASU classes.
Hello, I'm Brad Jubber. I have 10 years experience working with Boeing and United Technologies in aerospace engineering and lots of experience programming.
Bitcoin mining in and by itself is a complex topic to comprehend, and building or optimizing one is no exception. The goal and challenge the team is trying to solve with Bitcoin mining is to decrease the amount of power being used up or dissipated when running the SHA-256 hashing algorithm for mining. If successful, this can have a positive effect on the environment and may reduce overall operational spending costs. In order to achieve the aforementioned, the scope is understanding logic design, cryptocurrency system design, as well as others. An objective of our project is to design and optimize Bitcoin miner using system Verilog to measure the improved performance on an FPGA.
Here's a quick demonstration of our proof of concept. It's a double shot 256 hasher. We have it running on our FPGA board right here. I will speed up and run through the cycles here. Two sets of 64 cycles, but at the end, we end up with our desired output that matches our calculations. Once complete, I can use the switches to select which portion of the output is viewable and match that against our pre-calculated values. This is an important milestone in our project. We now have an unoptimized version that we can start implementing optimizations on top of. Another quick demonstration, we got serial communication working over USB to our device. I am able to both send and receive data, as you can see here. Here I'm pressing keys in the computer that are being sent over USB, and their binary equivalent is being shown on the LEDs. Using the switches below the LEDs, I can enter a ASCII character in binary, and by pressing the button, it will send it back over the terminal, as shown here. This will allow us to quickly send and receive data to our device.
As far as our scheduling and budget, we had gotten a bit behind schedule last semester and weren't able to finish the proof of concept in the time that we wanted to. But after working over winter break, we're now back on track. We currently don't have any items in our budget, as everything we need for the project we either already have or can get for free.
Building off Ben, leaving fall semester, we found ourselves behind schedule. So we worked at it during winter break and are now back on schedule. Looking at our updated milestone timeline, we are here, highlighted in yellow. We still have quite a ways to go, but some of our bigger milestones and future work plans include starting to convert our logic flow diagrams, code models if you will, into code and adding the optimized code chunks into our base code that we finished developing during winter break. We have 3 to 4 iterations of this, along with testing and verifying each iteration of the code still outputs the correct hash value. Lastly, after all optimizations have been tested and verified, and after all optimizations have been compiled into our new base code, we will run a performance test to see how our hash rate and power consumption have been impacted. For the team's final demo, we plan on giving a brief overview of how SHA-256 encryption works, along with showing logic flow diagrams. Then we will be showing and talking to each optimization by showing and describing with our code models what is happening and how the original base code can be and is shortcutted in our optimized version. After completing the theory portion of the demo, we will show a video demonstrating the speed difference between the two code bases.
In conclusion, while we've made several minor changes to the project, the fundamental idea remains the same as it was at the beginning of the year. We are currently on track to complete this project by the end of the year, and we are happy with our progress.